Okay, our topic for today is simplifying variable expressions. So what I'm going to do is give you like a formula for this type, and then we will work on what kind of this all means. So when you simplify, you're trying to get everything into its very little form, where you can't do anything else to it. So an example of simplified form is like 4, 6. 4, 6 actually can be reduced to 2/3. That is what we call the simplified form. It's just getting all the fractions, everything into its lowest terms, its lowest possibility that you can't do anything else. So that's pretty much what simplified is about. So let's go into this simplifying variable expression. Variable means that you have some kind of maybe some letter. Usually in math, it's usually X. Sometimes it's usually Y, and sometimes you can get a different letter like A. And really, you're just trying to plug in numbers to get something working, to get some kind of answer. So let's look at this formula here. This is a formula about Fahrenheit in Celsius. So in America, we use the Fahrenheit scale, F. In other countries, in most of the world, they use centigrade. We can use centigrade here too. If you know some facts about this formula, let's say that if C equals 0 degrees Celsius, what would be Fahrenheit here? Or how you convert Fahrenheit? So all you really have to do is do this. Take this value where you want to see where is C 0 degrees, where is Celsius 0 degrees. So you would go F equals 9/5, and then what you're going to put right here is you're going to put the variable that you put into there, that you want to find. So you're trying to, so think of this as kind of like an input. Think about this as like an input. You're putting something into the machine to produce something out of the machine. So let's say you want to put scrap metal and you get some kind of door of a car. You put some cans, like aluminum cans in, and you get something else. It's kind of interesting that way. So think about, you're going to take this and you're going to put it here. So you're going to go 0. So really you're just substituting. You're just substituting. You're subbing. You're subbing. You're putting this input in this equation. And now you should be able to get me the Fahrenheit scale. So you're going to go like this. You're going to put F because you're trying to find F. What is 9/5 times 0? Times 0. Well, anything times 0 is 0. So 0. But what else do you have there? You have this 32 that is always coming down. So you're going to go plus 32, or F equals 32 degrees. So there you go. So you're saying at 0 degrees Celsius, you have a Fahrenheit of 32 degrees. Well, think about this. In Fahrenheit, what is 32 degrees indicate? It indicates the freezing level in Fahrenheit. Well, Celsius is also the freezing height. So that's pretty much what you're doing with this. You're just taking some value and plugging it in. So you're taking some value and plug it in where you see that letter. Okay? So let's do another one. So let's say that I do, what if I wanted to find 100, let's say 100 degrees Celsius. Well, what is 100 degrees Celsius? Isn't that, in Fahrenheit, isn't that going to be steam, or where steam gets developed? So what you're going to do, you're just going to do the same thing, but now you're going to take this out, and you're just going to go ahead and put 100 in there this time. So you're just taking, so now your new input is this. And so you just have to work out the equation and to find the F. So what if I did this? So F equals, well, now you have a fraction, and many students don't like fractions. I don't know why, but really you have this. You have 9/5 times, well, how do you write 100 as a fraction? Well, isn't 100 divided by 1? Isn't 100 divided by 1? 100 as a fraction? Well, now, what do you do now? How do you multiply fractions? Just straight across. So 9 times 100 is 900. 5 times 1 is 5. So now you're just thinking, how many 5s go into 900? Well, I hope you remember how to do this. You go 900, 5. How many 5s go into 9? 1. So that's 5. That's 4. Bring down that. How many 5s go into 40? Let's see, 5 times, is that 8? 8. Make sure I do my math correctly. So then you have 5 times 8 is 40. So that's going to be 40. 0. Bring down the 0. Remember, you bring down your 0. How many 5s go into 0? Yeah, 0. 0. So now that's 180. Well, so put that right there. So that's going to be 180. What are you missing? You're missing this 32 all the time. Remember, some individuals, some people, they forget the stuff on the outside. They think that, well, oh man, I got the answer to be 180, but I forgot the 32. You got the rest of it, and that's what messes a lot of students up. So, what do you do now? Just simplify. Just simplify. You're adding what you can. So when you add this, you should have F equals, let's see, that should be 212 degrees Fahrenheit. And yes, that is where you get boiling temperature. So this is your boiling temperature. And that's where at 100 degrees centigrade, this is also the boiling temperature in Celsius. So that is pretty much what you're doing for this. So I want to kind of show you some more of these so you get kind of fluent with other formulas and also other ways of interpreting this a little bit. So hopefully that was okay. Like again, you have to understand what you're kind of aiming for in a lot of this. So let me just give you a few more. What if I did this? Maybe some of you will recognize that from recent years. This is the area. This is, the area of a circle. This is the area of a circle. And remember what r was? It was the radius. Pi was that number of 3. So pi was just like a 3.14. So you already know most of this already. You're just trying to find what the area is in that circle. So what if I gave you some r values? What if I gave you some r's, some radiuses? Well, what if I said, find the area, and we're going to make this easy on us. We're not going to try to overdo this because you don't need a calculator for this. So I want us to make pi be just 3, just because it's a little bit more simpler. It was originally 3 a long time ago, until other Greeks and other mathematicians actually found out that it was actually not just 3, it was 3.17, 3.16, now it's 3.14. But that's another story, another day. All right, so we're going to go ahead and just say pi is 3. We're just letting pi be 3 right now, times parentheses squared. Why do you think I put the parentheses there? Because that's what I'm trying to find. That's what I'm trying to plug in to get the answer out. So, what if I said I want a circle? I want a circle of radius 2. What if I want a circle of radius 3? What if I want a radius 1? So these are your numbers that you are going to plug in to this r to get me the area of that circle. And this is very helpful to get area of a circle because let's say you wanted to paint a big circle and you wanted to fill in, you wanted to paint inside of it or an object. Well, you need to know what the dimensions are. So let's say, or maybe, another example is like a sprinkler. And you put a sprinkler on some grass and the sprinkler is going around like this and you want to make sure, well, I want to see how much it is spraying or how much it can go. Well, that's what this can use because you're trying to find the area around where that sprinkler goes, it covers. So some of this is helpful. Okay, so you're going to go ahead and just put these values in. So I'm going to try to do this as best I can. So let's say that, use this one. So if I put 1 for here, I'm going to go ahead and go 3. Well, what's 1 squared? Remember PEMDAS. Please excuse my dear Aunt Sally. Some of you remember it as GEMDAS. So some of you remember it as GEMDAS. Grouping symbols, it's the same thing. So 1 squared is 1. So what's the area of this? Well, 3 times 1. Well, what did we let 3 be? Well, remember we let 3 be pi? Well, actually, that is pi. That's the radius of 1, or 1 is actually pi. So that's kind of where pi is coming from. Okay, so that was good. We got that. So now, I'm going to just erase this because I'm trying to save some time and some space for you. Well, what's our next number? Our next number is going to be 3. So what if I put 3 now in there? And do my order of operations, PEMDAS, GEMBOS. GEMBOS. So now we're going to go 3 times 3. 3 times 3 is 9. So you got 27. So for an input of 3 into our equation, you get 27. Okay? So that was good. So now we're going to go ahead and put in next number. So let's put in 2. Okay? Now if we put in 2, we got 3 times 2 times 2, 4. And we got 12. So when the radius of that circle is 2, you get 12. So really, you're having 3, 27, and 12 is your outputs. And that's pretty much it of this, is that you're just trying to put in some information to get some information out. So let's give you some more, and then hopefully you get a little bit more practice with this. So you might find that this is hard or complicated to a certain extent. Okay? But it really isn't. You're just plugging in some values. So what if I gave you something like this? So here's your guy. Okay. Something, maybe an equation like that. Or maybe this is an expression, maybe this is some kind of formula. And I got one over here to show you too. Okay, so what if I said there's a variable in there? There's that variable in there. There's that variable right there. Okay, that's that variable that when you put something in, you get something out of it. So what if I said to you, let x be 1? What if I said let x be 0? Well, you're just going to take these values and plug them in where you see that number. So you have 3 parentheses, 2 parentheses, -1, -3. Do you see why I'm putting parentheses? Why am I putting parentheses? Because I'm trying to now, this is that number that I'm going to put into here. So I'm going to go put 1 and 1. That's my number that I'm inserting. So now you just do some multiplication. 3 times 1 is 3. Minus 2 minus 3. And just do some PIMDAS. Well, what's plus 3 minus 3? 0. So your answer is 2. So you can go over here and just go minus 2 is your answer. And that's all you're doing. You're just taking some values and plugging them in. You're just taking some values and plugging them in. So let's try the second one. So we're going to take 0 and plug 0 in. So here's 0, 0. And then just go ahead and simplify it. 3 times 0, 0. 2 times that is 0 minus 3. So minus 3 is going to be your answer. And that's all you're doing. You're taking something, you're plugging some values in, and you can do this repeatedly. Okay? So maybe you're probably saying, where do you use this in real life? Well, I showed you the Fahrenheit. I showed you the area of the circle. Maybe you're interested about something that drops. And when I mean something that drops, we have gravity. We have gravity that drops. So let's say that I gave you something like this. -16 t squared plus 2. Actually, let's make it a little bit interesting. let's put 10. This formula, or this expression for now, it's not an equation yet because it doesn't have an equal sign, but this expression tells us something about the acceleration of gravity. So many students really find this really hard, is that when you have an object and it goes down, it's going to drop at some rate. Well, this equation is actually right here. This part right here is actually the acceleration of gravity, how much it falls. So what we're going to do is that we're going to take something like this and we're going to figure out some stuff. So maybe I drop something. Well, I want to figure out when t equals 0 time, so it hasn't left my hand yet. What about at t equals 1 second? What about when t equals 2 seconds? So what I mean by that, at 0, it hasn't left. At 1, I drop. So at 1, I drop. And then at 2 seconds, it keeps going, right? And that's kind of what we're doing with this. So we're just going to take these times, so these are time, and we're just going to plug them in for this time with this information. So we're just going to go negative 16 parentheses, just like that. And now let's do 0. Well, 0 time. And then just do the numbers. Well, let's see. What is 0 squared? 0. What's 0 times negative 16? Well, that's 0 plus 10. So you're saying at 0 time, it's 10. 10 feet. 10 feet, probably fine. So that's the first one. Well, what about the second one? Well, let's put in 1 second. After 1 second, it falls. Okay. So 1 squared, 1 times 1 is 1. So we got 1, and we got negative 16 plus 10. Well, what is negative 16 plus 10? You got more negatives than this one. You have 6 more negatives, right? Or 6 more negatives. Is that correct? Yeah. So this one is actually going to be negative 16. Or sorry, negative 6. Negative 6, if we do that math right. Oh, it's negative. Okay. Well, what about the next one? All right. So we're going to put in 2 here. And now we put in 2 here. Okay. So now, 2 times 2 is 4. So this is negative 16 times 4 plus 10. According to order of operations, or PEMDAS, we do multiplication first. So let's see, it says that 16, 32, 16, 32, is it 64? So negative 64, I do my math right? Now what is negative 64 plus 10? Well, that's going to be negative 54, correct? So for this value, you should have negative 54. So here's your values. At 0, it's 10. At 1 second, it's negative 6. At 2 seconds, it's negative 52. Now, before I let you go on this, what do you think's happening for here? So we have, this is increasing. Well, this is going up. So if you wanted to do it this way, that's going up. Well, what's happening here with my numbers? what's happening with my numbers here? Well, they're going down. They're going down. So that's not right. How can, if my times go up, how can my distance go down? Well, think of it this way. And this will be the final thing here. You release something and it falls. Sooner or later, it's going to hit the ground. So realistically, here's what's happening. Here's the ground. I can spell right. Here's the ground. Okay, there's the ground. You're taking the ball or whatever object and it's here. Well, you're dropping it, it goes to the ground. Well, technically, it hit the ground somewhere between 0 and 1. It hit the ground somewhere between 0 and 1. And you'd be like, well, it's a decimal then? Yes, it is. But our numbers are saying this. Our numbers from, let's say, 1 to 2 means it's going into the ground. It's still falling. So once you become a little bit more an expert at these kind of equations, you're going to see something like this. You're going to see kind of something like this. It's like a parabola. And maybe you fire like maybe you throw a ball. If you throw a ball at a certain speed, it's going to kind of go like this in a form, and then it's going to hit the ground somewhere. But we're just dropping the ball. So that's for another time. So hopefully this worked. Hope you know what simplifying variables are. Variables are the stuff that you're putting inside. And it's like you use them times, and you just do the GMDOS, PEMDAS, still the information that you learned a long time ago. All right, have a good one. Thank you.